I know we kind of started it a little bit. Has anyone seen a derivative in here? Anyone had pre-calc at all? Because the gift I will give to you is we get to leave our derivatives dirty in here, meaning we don't have to simplify them after we do the derivative, which is kind of cool. So I'm testing to see if you know how to do the derivative, not if you can do the algebra. Yo, see ya. All right. Gotta get this fired back up. Happy? All right. So, let's talk about some derivatives. Now, there is a long, drawn-out version I'm going to just basically show you. You've actually done it a couple times already. And then I'm going to show you the much simplified version of it. Okay? So, if I have f of x is some equation, first off, we will say f prime at x. This means take in first derivative. Okay? So, you could take really as many derivatives as you want until you get down to the constant. The derivative of a constant is 0. So if I had d over dx of some constant, oh, and I'm on derivative notes, business calc derivative notes. If I take the derivative of the constant, it becomes 0. All right. So let's say I had y equals x. Taking the derivative, things that you have to know. This has a exponent. If I have just x sitting there, x to the first is the same thing as that. You bring the exponent down and then reduce by 1. So this becomes 1x, 1 minus 1, which is 1x raised to the 0. Something raised to the 0 power is, anybody?
0.
No. 1. So this becomes 1 times 1, which is just 1. Okay? So that's the first thing to go through. So if we had the next one, if we wanted to find this derivative, if we had y equals x squared, and we wanted to find the derivative of that, I'm going to bring the exponent down, reduce the exponent by 1. That's your derivative. Okay? If I had something that was raised to the third power, this becomes 3x raised to the second. And if I had something raised to the n power, this becomes y prime. Y prime equals nx n minus 1. Okay? So basically the first thing to really realize is whatever the exponent is, whatever the exponent is, you reduce it by 1, you bring it out to the base in front. If there's a number out in front of the base, you multiply the exponent itself together, and then you reduce the exponent by 1. Now, that's just a pretty straightforward, simple situation. But what if we had something like this? What if we had something like this? I wanted to find the derivative, see if you can follow what I'm doing. This comes down, that becomes 6x to the first. Agree? This is to the first, this comes down, this becomes 5x to the 0. Derivative of a constant is just 0. Clean this up, because this becomes 1, so that's 5 times 1. Okay, very simple way of doing it. The rule works, excuse me, the rule works the same way if you are subtracting. And there are some other rules that go along with these. I'm not sitting in you guys' way, am I? I'm sitting on my desk. Okay, just making sure. All right, so let's do this. On the bottom of that page, it says derivative type question. Write the equation of the line tangent to f at x, or f at x equals square root 16 at x equals 16. That's actually a silly one. Let's go down to the second one. Let's find the slope of the tangent line at f at x equals x squared, at x equals 1, x equals 2, and x equals negative 3. Okay? You told me you were going to your car. I'm so sorry. Monday shenanigans in my brain. All right. So first off, let's kind of explore what x squared looks like. It's a parabola. Agree? If I jump over to Desmos, and I just go y equals x squared, oops, y equals x squared, it's a parabola. So what we want to do is we want to figure out what the tangent line, find the slope of the tangent line. So a tangent line is going to be this line that just comes down. It's a straight line. It touches our graph one time. So we're going to touch it once here at 1. Wherever 1 is on here, let's widen this so we can get. So we're going to do what's happening at 1. What's up? So I rearranged stuff, sorry. But you're welcome to sit there. We're going to see what's going to happen at 2. So at 2, roughly, what's the slope right there of the tangent line? And then at 3 as it widens out. Okay? All right. First thing I want to do, I want to take the derivative of this. So I'm going to change f of x. I'm going to change it to y equals x squared. Take y prime. That's 2x to the first. Agree? Okay. As soon as you find the derivative, you're going to take this value and plug it in. So I'm going to get 2 times 1, which is a slope of 2. This one, I'm just going to plug 2 times 2, so I get a slope of 4. This one I plug it in, 2 times negative 3, that's going to give me negative 6. So that's what the slope is. Okay? So the slope, as it changes, again, we're talking about a straight line that takes place up here. If I go back to the home of this, this is what's taking place. I have a meter stick someplace. I thought. Unless my freshman ran away with it. Anyone see my meter stick anywhere? Am I getting warmer? Yeah, we'll make it work with this straight edge. So basically, if I had this is a straight line. As it comes down, notice the slope of this hole puncher is changing. I have a negative slope here. Right down here, I have a slope of 0. I have a positive slope. Okay, when I say slope, it's the exact same thing that it means in Algebra 1. The slope is just a straight line. It's the rise over the run. Vertical slopes are undefined. Horizontal slopes are 0. And then we have positive, negative slopes. Okay, so that's the first thing to kind of think about. Now, we're going to get to a point where we will find the equation of the tangent line at that exact point, but we're not quite there yet. But we'll get there. All right, so at the bottom, I bet you guys can do these pretty quickly with me. F at x equals 7x minus 4. So f prime at x, what do you think? Derivative.
1.
Not 1. What's my lead coefficient?
7.
Yeah, so it just comes out to 7. Okay? Hey. Good to see, brother. about b at that bottom? It says f of x equals x to the third minus 2x squared plus 10x. What's our derivative going to be? What's the derivative of this?
2.
Well, it's x to the second. What comes out front? See where the 3 came from? You see where the 2 came from for the exponent. What's the derivative of this middle part? And don't forget that. Minus 4x. Derivative of this plus 10. So the rules on a derivative, for a basic derivative, take exponent out front, multiply if number's already there. Reduce or subtract 1 from exponent. Pretty simple terms. All right, let's see if we can walk through this. F at x equals x to the 100. What's the derivative? Bring the exponent down front, which is 100. Subtract 1 from the exponent. Done. What if I had this? What's the derivative of that going to be? 60x to the 19. Good. Okay? It's as simple as that, especially on these first few. Okay? All right, a couple of things that we want to realize is, let's say I have a weird picture like this. If I wanted to figure out what the slope is at any one of these points, M meaning slope. You with me on this? If I found the slope of this slope would be positive. This slope would be 0 because that would be a horizontal line. This slope's negative, this slope's negative, this slope's 0, this slope's positive, this slope's positive. Okay? That's called the instantaneous rate of change at an exact point. If I had a graph, let's say if I knew that this point right here in the x direction was 3 comma, I'm going to just put a question mark because I'm not worried about it. If I found the derivative at this point, so this could be y equals x to the third, could be this graph. So the derivative of that is going to be 3x to the second, which means I'm going to take my 3, plug it in there. So if I wanted to find my exact slope at that exact point, it's going to be this math. So this is now our slope at that exact point. Okay? It changes as you go through. Again, you're talking about, you're kind of getting to the point where we're starting to look at a tangent line. A tangent line is a line that touches the graph one time. Is the tangent line the straight line that touches it once the same thing as tangent and sine, cosine, tangent? The answer is yes. It is very much related to it. So what we're going to be getting to is, if I had this value here and I wanted to find this, I could figure out y equals mx plus b of this line. That exact point, we could find the slope of that exact point once I take the derivative and I plug whatever that x value is back into the derivative, and it should work. Things to know for your assignment, and I keep going with this type of situation. Let's call this point A, let's call this point B. So this point right here, we are increasing from negative infinity until A. Okay? From here to here, from A to B, we are decreasing from from A to B. And then right over here, we are increasing again, and that goes from B to infinity. When I say increasing or decreasing, increasing means slope positive, whereas decreasing, slope negative, or not negative 0, just negative. And then exactly at point A, slope is 0, because I would have that as my tangent line. At B, we also have a slope of 0. Okay? So again, the tangent line is this obscure looking thing. Let me just show you what a tangent line would look like. And I don't think we have to get to this, but I just want you to see what it does. Let's say I have y equals 2x to the third. The derivative of this is going to be 6x squared. Agree? Let's say I have the point 2, 3 is on our graph. And we want to find the slope at that point. So I'm going to take my 2, I'm going to go 6 times 2 squared, which is 6 times 4, which is 24. So I get a slope of 24. Okay? But let's say I knew that this was a point on my graph. So if I took and used y minus y sub 1 equals m times x minus x sub 1, this is called point slope. Desmos will use this very easily. So now we know the slope. This is x1 and this is y1. So I'm going to go y minus 3 equals 24x minus 2. And if I use Desmos, I'm going to show you what this is going to look like. So I have my equation I just made up was 2x to the third. And then down here, I'm actually going to plot this point. We said 2, 3. So I want to plot the point 2 and 3. And it works better when I find a point exactly on there. Let's not do 2, 3. Let's go 2, 8, 2, 16. I'm going to change this 3 to 16. That means that this has to be y minus 16. Okay, so this point right here has a single tangent line that kisses it. So somebody write this equation down for me because I'm going to have to keep going back and forth. Y minus 16, you got it so far? Y minus 16 equals 24 parentheses x minus 2. 24 parentheses x minus 2. And let's change our color on this to black. No, yeah. Alright, this black line, if I scroll in far enough, you should start seeing the red going away. This is obviously a slope of 24. You go up 24, right 1. That's as far as I can go back to home. So that black line is a tangent line to the red line at the point 2. That's the equation of the tangent line at 2 in the x direction. At 2, 16 is where the point exists on our actual line. Okay? So that's what we're eventually going to get to. So I think we could easily, hopefully, and by using Desmos, when you plug it in, you could actually hit upon this assignment pretty well. So this is worksheet 4.3. I think you guys could handle going through it. I'll give you the rest of the period to get a start on it. If you need help, please come and ask me. Happy to help you. Deal? I hope you guys have a nice weekend. Someone said that we're supposed to get like 15 inches of snow on Thursday. Dude, does that mean we start spring break on Thursday? Spring break with a snowstorm? Only in Colorado. Gotta love this state.